In this section, I will look at converting decimals to binary and hexadecimal, as well as look at the operation called AND. These skills are important to learn when you start dealing with IP addresses. If your career starts taking you more towards the networking side of things, understanding how to convert numbers between different formats becomes essential for creating and managing a network. In computing, you have switches, which can either be set to on or off. This gives you two possible values. To allow you to represent larger numbers, computers group these switches together. The most common one you will deal with is a byte, which is 8 bits or switches. The byte has a value of 0 to 255. To convert a decimal to a binary, I use the following table. Each bit in the table has a value assigned to it. You can see, going from right to left, the first value has a 1 in the first position. The second position has a value of 2, twice the previous value. The third position has a value of 4. As you can see, the values double in each position until the final value is 128. If I take a random number, say 174, and want to convert it into binary, I would do the following. First, I would go to bit 8 and work out if 174 is greater or equal to 128. If 174 is greater than 128, which it is, the result is a 1. I would then subtract 128 from 174 and place the result, 46, in the next column. The next column has a value of 64. 46 is not greater than 64, so the result is no and gets a value of 0. I now move 46 to the next column and compare it with its value of 32. 46 is greater than 32, so I place a 1 in this column and subtract 32 from 46 to give me 14. I keep following the same procedure throughout the table. You will notice that when I get to the second to last column, the value 2 is equal to the column value, and thus the result is still a 1. All columns after this will equal 0 since there is no remainder to subtract from the column value. This gives us a binary value of 10101110. Using this method, you can quickly and easily convert any decimal number into a binary number. With IP version 6, hexadecimal is used in the IP address, so you need to have an understanding of it in order to master IP version 6. If I were to take an IP version 4 address and convert to hexadecimal, I would do the following. First of all, I would convert the numbers into binary using the previously shown method. Once the numbers are in binary, they are easier to work with. The next step is to divide the binary into groups of 4. Dividing the bits up like this gives each group of 4 bits 16 different possible values. Hexadecimal uses 16 values, and thus that is where hexadecimal gets its name. It is a simple matter to convert these values into hexadecimal values. As you can see, each group of 4 bits has been given a value between 0 and 15. Once you have this value, you can use this table to determine the hexadecimal value. The first value, 12, gets a value of C. Values between 0 and 9 get the same value, so therefore the values in the example, 0, 9, 1, 1, and 3, all get those same values. It is not till we get to the far right that you will see the value 14 will get the value of E, and the value 10 will get the value of A. Certain IP version 6 addresses have IP version 4 addresses embedded in them. It is important to understand how to convert decimal to hexadecimal to understand IP version 6 addresses. Once you start working with more than one network, it is important to understand how the AND operator works. Consider this table. When comparing two bits, if both bits are 1, the result is a 1. You will notice that in all other cases, the result is 0. All it takes is one or both bits to be 0, and the result is 0. If you have trouble understanding this, think of the AND operator as a multiplication operator instead. 1 times 1 is 1. 1 times 0 is 0. 0 times 1 is 0, and 0 times 0 is 0. Why is the AND operator important? Later in this course, you will learn the AND operator is used to determine the destination of a packet. Consider this small network. If a computer sends data over the network to a server, the computer needs to determine if the data is to be sent directly to the server or the data needs to be sent via a router. If the server is on the same network as the client, it sends it directly to the server. If the server is on another network, the client computer sends the data to a router. By using the AND operator, your computer can work out where to send the data. Later on in the course, this process will be explained in much more detail. This has been a short introduction to converting decimals. If you don't work a great deal with the networking side, you may want to consider using the Windows calculator to convert decimals to hexadecimal and binary for you. Just remember to switch the calculator to scientific mode first. Before sitting for your exam, check the exam requirements. A lot of exams will allow you to use the Windows calculator in the exam. If you are planning to sit any Cisco exams, however, you need to have an excellent understanding of how to convert decimals. Cisco does not give you a calculator in the exam to help you, and believe me, you need to do the math fast. Lastly, if you need more practice, there are many resources on the internet. When I was first learning networking, I used a website called learntosubnet.com. This is a great little site that will help you understand how to convert decimals to binary and also how to subnet. I will cover subnetting in more detail later in the course, so don't worry if you don't understand it yet. For the present, just make sure you understand the basics of binary and hexadecimal. If you don't understand how to convert values, you can also cheat for the moment and use the Windows calculator.